welcome to another episode of our further mathematics class. Today we shall be discussing the topic that says binomial theorem and Pascal's triangle. Binomial theorem is a technique for expanding binomial expression raised to a given finite power. We take note of this by writing it down. Binomial theorem is a technique for expanding binomial expressions raised to a given finite power. Okay, this is the definition of our binomial theorem. Alright, let's take these examples of binomial expressions. If we have a plus b all raised to the power 0, this gives us 1. If we have a plus b all raised to the power 1, this will be what? A plus b. Okay, if we have a plus b all raised to the power 2, this will give a plus b multiplied by a plus b. So this becomes a times a to give us a squared, a times b to give us plus ab, a times b, okay, will give us another a, b, and b times b will give us b squared. Alright, this is what we obtained. Look at how we did it. A times a squared, a times b, ab, b times a, b times b squared. We have like terms here. Add them up, we have a squared plus 2ab plus b squared. If we look at this, we can obtain that the coefficient of a here is 1, the coefficient of ab here is 2, and the coefficient of b squared here is 1. So these coefficients will help us a lot to construct the Pascal's triangle, and Pascal's triangle is used also to determine the coefficient of terms that we are expanding by using binomial theorem. Okay, next is, let's have another binomial expression, a plus b, okay, raised to the third power. So if we have this, it simply means that a plus b, okay, raised to power 2 is being multiplied by a plus b. Okay, when this happens, we are going to have that this a plus b all raised to power 2, we have already done it, okay, and this is our answer. So this appears to be in this order. A plus b raised to the power 2 will be a plus b all raised to power 2. Okay? We have the answer to be a squared plus 2ab plus b squared. Now we have to multiply this by ab. Okay, we'll multiply by ab. Come here and multiply by ab. Let's see what it gives us. Alright. As we are multiplying, we are going to have b times b squared will give us b raised to the power 3. b times 2ab will give us plus 2ab squared. b times a will give us plus a squared b. A multiplies a times this will give us ab squared. A times 2ab gives us plus 2a squared b. A times a gives us a cube. And that is a raised to the power 3. So when we add up this, let's see what we get. Bring down b raised to the power 3 plus this add up will give us 2a plus a will give us 3ab squared. A squared and 2a squared will give us 3a squared b. Bring down what? A raised to the power 3. Okay. So when we multiply this a plus b all raised to the power 2 by a plus b, that is to get the a plus b raised to the power 3, we are going to have this. So what is the coefficient of a here? 1. What's the coefficient of a squared b here? It will give us 3. What's the coefficient of ab squared here? 3. What's the coefficient of b here? Is 1. So these coefficients will help us to get our Pascal's triangle when the time comes. Alright, that is it for the binomial expression a plus b all raised to the third power. Let's assume that we have a plus b, another binomial expression, all raised to the fourth power. So what does this mean? This simply means a raised to the power, okay, a plus b raised to the power 3 multiplied by a plus b. Okay, and we have our a plus b all raised to the third power to b. Write that here, a raised to the power 3 plus 3a squared b plus 3ab squared plus b raised to the power 3. So this is to be multiplied by a plus b. Okay? So when we multiply out this, let's see what it gives us. We are going to get b times b raised to the power 2 will give us b raised to the power 4. Alright. Put your plus. B times this will give us 3ab cubed. B times this will give us the plus. B times this will give us 3 a squared b squared. And b times this will give us a cube b. Then a multiplies. So a times this will give me ab cube. Okay, a times this will give me 3a squared b squared. A times this will give me plus 3a cube, that is a raised to the power 3 and b. Then a times a raised to the power 3 gives a raised to the power 4. If we add up all these values, let's see what is going to be. So bring down what? B raised to the power 4 plus this will give me 4a b raised to the power 3. This will give me 6a squared b squared plus this will give me 4a cube b. Okay, and here we have a raised to the power 4. Alright. Now this is what we obtain when we use multiplication to expand this binomial theory. Okay? Then this binomial expression now, when we use multiplication method to expand it, this is what we obtain. You can see the a raised to the power, a plus b raised to the fourth power, we are having the coefficient to be 1, 4, and here is 6, here is 4, here is 1. So we have 1, 4, 6, 4, 1 as the coefficient. Alright, we are going to ascertain this more using the binomial theorem formula to solve our work. Okay, we come over to this side, we erase this part of the board so that we can do this one here very diligently. Okay, we erase this part of the board. Let us take the binomial theorem formula and use it to solve. I know if we are going to get the answer we have over there. Okay, if we have binomial expression to the n power a plus b to the n power. It better we say summation, okay, and k equal to 0, alright, and choose k, okay, a raised to power n minus k, okay, and b raised to power k. This will keep on summing up, alright. We'll keep on summing up until k reaches towards the power given to us in the expression. So then I will have n choose k, that is n combination k, to be n factorial all over n minus k factorial times k factorial. Okay, this is what this n choose k here symbolizes. With this formula, let's use it and solve an expression that goes thus: a plus b to the 4th power. Alright, we are going to do it singly until we get all the whole values, then we sum the values up. So we start with the first one, summation. N is now 4, k is equal to 0, and we have 4 combination 0. Okay, multiplying a raised to power 4 minus 0 and b raised to power 0. Okay, let's see what this gives us. I'm going to cut out some part here for me to use it and do my calculations. Let me cut out some part here and call it my working space. Alright, having cut out this space, let's start. For me to get the coefficient now, I'm going to use 4 combination 0. 4 combination 0 will give us 4 factorial all over 4 minus 0 all factorial times 0 factorial. When we do this, we are going to have 4 factorial over 4 minus 0 is 4. Okay, 0 times this will give us 0 factorial. And 4 factorial over 0 factorial is what? 1. So our coefficient here now will be 1 times a raised to power 4 minus 0 is 4. B raised to power 0, any number raised to power 0 is 1, except 0 raised to power 0. So b raised to power 0 will give us what? 1. So we multiply here by 1. Our answer will now be 1 times a raised to power 4 will give me a raised to power 4. We write it down. Let's take the second part, the summation. Okay, n is still 4, and our k is no longer 0 now, but 1. Then I'm going to have 4 combination 1 to multiply my a raised to power 4 minus 1 to multiply my b now raised to power 1. Alright, let's get our 4 combination 1 here. 4 combination 1 will give us 4 factorial over 4 minus 1 all in factorial and 1 factorial. So at this juncture, I'm going to have 4 times 3 factorial over, this will give me 4 minus 3, 3 factorial, times 1 is still 3 factorial. So this cancels. I have what? My coefficient here to be 4. So here will now be 4 times a raised to power 4 minus 1 will give me a raised to power 3 times b raised to power 1. Okay, we can leave it as b. So what we have here now will be 4a raised to power 3b. Okay, the next one will give me summation 4, k is now equal to 2. Right, k is equal to 2. Then I will have 4 combination 2. Okay, when I write down this, it will take me to this level now, times a raised to power 4 minus 2, okay, times b raised to power 2. Alright, let's show our work in here. Okay, the first part is this, second part is this. So the third part, we have 4 combination 2. So our 4 combination 2 will give us 4 factorial all over 4 minus 2 all in factorial times 2 factorial. So this becomes 4 factorial over 2 factorial 2 factorial. So this will give us 3 times 2 because this is 4 and the other one will remain what? 4 times 3 times 2 times 1 all over 2 times 1 2 times 1 times 2 times 1. Now this is 4, it cancels out this 4. So 3 times 2 times 1 is 6. Therefore, for this, we are going to get that this 4 combination 2 is 6 times A. 4 minus 2 is 2. Then b raised to the power 2 is what? This. We write it out. This is what we get after solving for k equal to 2. Then I will raise this part of the board to continue our task. I will raise this part of the board to continue our task. Okay. So far so good. We're using the binomial theorem formula to solve a plus b all raised to power the 4th power. Okay. So now that we have our k equal to 2, let's get our summation for k is now equal to 3. Then we have 4 combination 3. Let a raised to power 4 minus 3 and b raised to power 3. Okay, we can also come here and put out the workings. So when we do that, I'm going to have 4 combination 3 will be 4 factorial over 4 minus 3 all in factorial, okay, times 3 factorial. So this will give me 4 minus 3 is 1. So I'm going to have 4 times 3 times 2 times 1 all over. This is already 1 times, this will be 3 times 2 times 1. This cancels. We have that our coefficients here will now be 4. A raised to power minus this will give us what we give it. So right now b raised to power 3. So this is what we get for k equal to 3. So let us also get the value of k equal to 4. When k is equal to 4, we have 4 combination 4 a raised to power 4 minus 4 b raised to power 4. 4 combination 4. Let's see what that be. To be 4 factorial over 4 minus 4 factorial, 4 factorial. So this will automatically give me 4 factorial over 4 minus 4 is 0 factorial. 0 times 4 factorial will give me what? 0 factorial. So 4 over 0 factorial, 4 factorial over 0 factorial will give us 1. So the coefficient here is what? 1. When we write it, or we can write it 1 times a raised to power 4 minus 4 is 0. So a raised to power 0 is 1. So we put what? 1 here. Okay? Times b raised to power 4. At the end we have b raised to power 4 after the multiplication. Okay? We have summation. They say we should add up these things. We should add it up. The first one that we obtain says a raised to power 4. Okay? Plus the second one we obtain says 4a cubed b. Okay? The third one says 6a squared b squared. Alright? The next one is plus 4ab cubed. And lastly we have plus b raised to power 4. You can see that this is similar from what we use multiplication method to do when we have a plus b all raised to the 4th power. Okay, see it here now. When we use the binomial theorem formula, we still obtain the same answer. And that time we have that the coefficient is 1, 4, 6, 4, 1. Same thing here, 1, 4, 6, 4, 1. Alright, next we have is Pascal's triangle. Want to use Pascal's triangle to get the coefficient of binomial expression. Pascal's triangle. Okay, we are going to also generate the triangle after this definition. Alright, so far so good. We have covered the definition of binomial theorem. Now to work with. Now, Pascal's triangle says it is the arrangement of numbers that give the coefficient. It is the arrangement of numbers that give the coefficients. Okay, let us write it down. It is the arrangement of numbers that give coefficients in the expansion. It is the arrangement of numbers that gives the coefficient in the expansion of binomial expression. So Pascal triangle, it is the arrangement of numbers that gives the coefficient in the expansion of binomial expressions. So let us generate the Pascal's triangles over here. Alright, we'll start. Okay. As I'm erasing this part of the board, you will see that all those things we did in the multiplication of the binomial terms and using the binomial theorem formula will take good shape now. Okay, from here, the first expression we have says a plus b to the raised to power 1. Okay, for Pascal's triangle, we write our 1 here. For this, it will be a plus b raised to power 2. Then we have 1, 2, and 1. We have a plus b to the third power. We have 1 plus 2 will give us 3, 2 plus 1 will give us 3, and we end it with 1. Next is a plus b to the fourth power. We have 1 plus 3 will give us 4, 3 plus 3 will give us 6, 3 plus 1 gives us 4, and with 1. Next will be a plus b to the fifth power. This will give me 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4, 10, 4 plus 1, 5, and with 1. If we have a plus b to the sixth power, I'm going to have 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 5 plus 1 is 6, and with 1. Okay, what if I have a plus b to the seventh power? This will give me 1 plus 6 is going to be 7, 6 plus 15 will give us 21, 15 plus 35, 15 plus 20 is 35, okay, 20 plus 15 is another 35, alright, 15 plus 6, 21, 6 plus 1, 7, we end with 1. Okay, this is how it keeps on going, so if we take this shape from this point down, okay, from here down, we are going to get a shape that looks like this. We take from this point downwards as well. Let's see what we're going to have. Okay, to the shaping. So we connect them here. Let's see if it will give us a triangle. Okay, actually it gave us a triangle. So what is the essence of this? This is to enlighten us to know the coefficients that we're going to get whenever we're doing binomial expression. Now, if we have a plus b to the second power, the coefficient of the terms after multiplication will be 1 to 1. If we have a plus b to the third power, the coefficient of our terms after that will be 1, 3, 3, 1. And if we have a plus b all to the fourth power, we are going to have 1, 4, 6, 4, 1 as we have here. Okay? So this gives us a clearer picture of how the coefficient of our terms will be. Now when we have a higher power like 8, 9, 10, we keep on expanding this Pascal's triangle to get the coefficient, and this will help us a lot to know the values of the coefficient, and we have had so many errors by doing so. Okay, this marks the end of this class. See you on next episode, and do me a favor to click on the bell icon for notification, share this video, let it go viral, and okay, subscribe if you haven't done so. Bye for now.